Assalamu alaikum everyone. This is Fahan Sari and I'm here to help you conquer chemistry. In this video we will be looking at percent composition and percent purity. So without further ado, let's get right into it. So the percent composition is the percentage by mass of an element in a compound. Very simple definition, and the formula for calculating this percentage is very simple. So in order to calculate percent composition, all you need to do is use the AR of the element and multiply it by the number of atoms in the formula of the compound. You divide it by the MR of the said compound and then multiply by 100. So in case you don't know what AR and MR are, basically, you can watch my previous videos which explain this in quite a bit of detail, what an AR of an element and MR of a compound mean. So let's do some examples. So percentage by mass or percent by mass of nitrogen in this compound over here. So I have nitrogen which has an AR of 14. You can look this up from the periodic table. And we have 2 atoms of nitrogen in this compound. So that's 14 times 2, and then we divide it by the MR of this compound. So you should know how to calculate MR by now. It turns out to be 60, and we're going to multiply this by 100%, and this comes out to be 46.7%. All right. Let's say we now want to find the percentage by mass of nitrogen in ammonium phosphate, right? This is the compound. So for this, we will have 14, the AR of nitrogen, once again, from the periodic table. We have 3 atoms of nitrogen in this case, so that's going to be 14 times 3. And you divide it by the MR. And in case you're wondering how to find the MR, all you need to do is add up the ARs of these respective elements, all right? And it comes out to be 149 in this case, multiplied by 100, and you get 28.2%. Now let's say I want to work with another element. Let's say I want to work with phosphorus in the same compound as used in the previous example. And now we have only 1 atom of phosphorus, so that will be just 31. The AR of phosphorus, you don't need to multiply this by anything. Divided by the MR, which remains the same as previously stated, which is 149, multiplied by 100, and it turns out to be 20.2%. All right, so these are very simple methods of finding percent composition of elements in certain compounds. By the way, one daily use of this is to mention percent compositions of 3 specific elements, namely nitrogen, phosphorus, and potassium in fertilizers. So for example, for urea, you can see that the percentage compositions have been mentioned as this over here, 46.00 over here. This is basically the NPK value, or the percent composition of the fertilizer, which is nitrogen and then phosphorus and then potassium, right? And by the way, this first example that we used, this compound over here, I didn't take the name of this before, is in fact urea, and we found the percent composition of nitrogen in this, which is 46%. They've rounded it off to 46. And we know that there's no phosphorus and no potassium in this, so that's why these 2% compositions for these 2 elements in this compound, urea, are 0. Now on to percent purity. This is the percentage by mass of the desired component. This could be an element or a compound in a mixture containing the component alongside impurities, right? So, for example, you have a certain mass of a mixture, and there's one component in this that you want to separate from the remaining impurities. And you want to find what is the percent by mass of this mixture that is actually the desired component. So for this, you just divide the mass of the desired component by the mass of the entire mixture and multiply by 100. So very simple example, let's say we have a mixture of many different components, right? But a certain part of this mixture is a component A, and the rest is just impurities. This is the stuff that we do not need, and A is the component that we do need after separation. So let's say that after separation, it turns out that A weighed 40 grams, and the entire mixture, including the impurities before separation, weighed 50 grams. So the percent purity for this particular mixture would become 40 grams, which is of the desired component A, divided by 50 grams of the entire mixture times 100% equals 80%. So the mixture turned out to be 80% pure when we consider the desired component to be A. If the desired component was something else, something within these impurities, then the percent purity would change accordingly. Now we will do an example from a past paper, which is much more complicated than what I've just told you. And it actually involves certain calculations involving titration, right? So let's get into it. So it says sodium nitrite is a decomposition product from heating sodium nitrate. A student analyzed a sample of sodium nitrite by titration with aqueous cerium-4 ions. So basically, what is titration? A titration is basically a reaction. It's a reaction between two solutions, all right? And we have already seen what a solution is and how to find concentrations for solutions in a previous video. You should watch that before getting back to this. All right, so the equation for the titration reaction between the two solutions is shown. So one solution contains these nitrite ions, NO2 negative, and the other solution contains cerium-4 ions, this Ce4 positive, right? And this basically results in the products given. Now, two steps. Now, first, it says that 0.138 grams of impure sodium nitrite was dissolved in water and made up to 100 cubic centimeters in a volumetric flask. That is how they prepared this first solution, right? And then they say that 25 cubic centimeters of this solution that was prepared in step 1 was basically reacted with cerium-4 ions, and it says that it required 21.8 cubic centimeters of 0.04 mole per cubic decimeter cerium-4 ions to reach the end point. All right, and it says calculate the percentage purity of the sample of sodium nitrite. Right, so now in these two steps over here, first you've made the first solution of sodium nitrite. Basically, you took an impure sample of sodium nitrite. Sodium nitrite was the desired component mixed with some impurities, and that added up to 0.138 grams. This was mixed in 100 cubic centimeters of water, and that made up the first solution. And then 25 cubic centimeters of this solution required this particular volume of this particular concentration of the second solution, which is cerium-4 ions. All right, to reach the end point, and the end point basically means the end of the reaction. All right, this is the point at which everything completely reacts with the other. Right, this is the end of the titration, or the end of the reaction between the two solutions. All right, so in a titration question, it always helps to work backwards. Right, so let's start with step 2. It says that 25 cubic centimeters of the sodium nitrite solution required this volume and this concentration of cerium-4 ions. So with the volume and the concentration, we can find the moles of cerium-4 ions. So the number of moles of cerium-4 ions becomes the volume of the solution, of the second solution, times the concentration, 0.0400. All right. And we divide the volume in cubic centimeters by 1000 because we want to convert cubic centimeters to cubic decimeters first, and then multiply by concentration in moles per cubic decimeter. All right. So once we do this, we get 8.72 into 10 to the power of -4 moles. All right. Another way of doing this is that you have 0.0400 moles in 1000 cubic centimeters. That's another way of saying 1 cubic decimeter. This is how I express the concentration as a ratio. So if I have just 21.80 cubic centimeters of the solution, then how many moles will I have? So basically I cross multiplied, and this is what resulted in this whole equation right here. All right. Now we have the moles. So now from this, we could find the number of moles of nitrite ions in 25 cubic centimeters of the first solution prepared in step 1. Right? Now in this equation, you can see that 1 mole of nitrite reacts with 2 moles of cerium-4. So we have the ratio of 1:2. All right. So from this, if we have 1 mole of nitrite, it reacts with 2 moles of cerium-4. So if we have already the moles of cerium-4, which is 8.72 into 10 to the power of -4, and on the other side we will have x, cross multiply, that basically turns out to be the number of moles of nitrite happens to be 4.36 into 10 to the power of -4 moles. All right. And once you found the number of moles of nitrite ions, remember, this is in 25 cubic centimeters of that solution. Now we need to find the number of moles of nitrite ions in the original solution. Now we go back up to step 1, which is 100 cubic centimeters. All right. So apply ratios again. So we have 4.36 into 10 to the power of -4 moles in 25 cubic centimeters of solution. So if we have 100 cubic centimeters of the solution, then what will be the number of moles? So we just cross multiply once again, and this becomes the number of moles of nitrite ions in 100 cubic centimeters turns out to be the previous number of moles times 4. That becomes 1.744 into 10 to the power of -3 moles. Now we need to find, using these moles, the mass of sodium nitrite in the total mass of the impure sample of 0.138 grams. Not all of this is sodium nitrite, some of it is impurity. All right. But for this, first of all, we need to know that in 1 mole of sodium nitrite, we have how many moles of nitrite ions? From the formula, you can easily see that in 1 mole of sodium nitrite, you have 1 mole of nitrite ions. So this is basically the same as the number of moles of sodium nitrite, right? Now we need to convert these moles into mass. So for that, we know that in 1 mole of sodium nitrite, we will have a certain number of grams of sodium nitrite, which is equal to the MR of this particular substance, which is 69 grams. All right. So in 1 mole of sodium nitrite, we have 69 grams of sodium nitrite. So if we have 1.744 into 10 to the power of -3 moles, we need to find the number of grams, basically the mass in grams. We will cross multiply, and so the mass of sodium nitrite happens to be 0.120 grams. Now that we have the mass of sodium nitrite, the mass of the desired component, now finally we can apply the formula that we were talking about on the previous slide, which is the mass of the desired component, which is 0.120, the mass of sodium nitrite, divided by the mass of the entire mixture, including impurities, which is 0.138. Multiply this by 100%, and you get 87.2%. So finally, after a lot of working, we have arrived at the percentage purity, or the percent purity, of the sample of sodium nitrite. Wow. So in this question, basically you used up a lot of concepts that you've learned previously regarding molar ratios and regarding concentrations and volumes of solutions and how to use them to find moles, how to convert between moles and mass, and then how to finally use percentage purity formula to find the percent purity of the sample of sodium nitrite. So if you like this video, don't forget to like, share, and subscribe to the channel. Inshallah, I will see you in the next video.